Hello friends, I welcome you all to my channel. Now today let's discuss an important topic of amines, that is nitrogen and its compounds, class 12 chemistry. Now today we will discuss about the optical activity of amines, whether amines are optically active or not, whether they form enantiomers or not. So basically if we see, then primary and secondary amines, primary will not make, but secondary and tertiary amines will show optical activity. Secondary and tertiary amines will be optically active, will be optically active. Why is it so? To understand this, now let us consider again the shape of the molecules. So basically amines are pyramidal in shape. In shape due to presence of one lone pair of electrons. But if we consider the lone pair as a group, lone pair present on nitrogen as a group, then definitely the amines having different substituents on nitrogen will be optically active. So, and in that case we shall have to assume its shape as tetrahedral somewhat. Actually its shape is pyramidal, वास्तव में इसका शेप पिरामिडल होता है, लेकिन अगर हम ऐसा माने कि इट हैज अ टेट्राहेड्रल ज्योमेट्री and consider the lone pair present on nitrogen as a particular group. So if the nitrogen has all the four different substituents, then that nitrogen will be chiral. So nitrogen containing or having different groups is chiral. So secondary and tertiary amines will show optical activity or enantiomers. So how they are going to show it? We can consider it with an example. Let us take the example of methyl, ethyl amine. So basically what is methyl ethyl amine? And there will be a lone pair. So if we consider, then the nitrogen has all the different groups on it. Here is the lone pair. This will form such non-superimposable image. A non-superimposable image will be formed. So here as we can see that this is the nitrogen and it has all the four different groups. One is ethyl, one is hydrogen, one is methyl, and if we consider the lone pair as a group, then all the four groups attached to the nitrogen here are different, and when such a condition is there, then definitely nitrogen will be chiral, and nitrogen is chiral, so it is going to form enantiomers, or it will show optical activity. So we can say that secondary and tertiary amines are optically active. We can find it, but as in case of carbon compounds, carbon is also chiral. In amines, like in carbon compounds, in amines we cannot resolve the isomers easily. Like in carbon compounds, isomers are resolved easily, whereas in case of amines it is not possible. In case of amines it is not possible to resolve the isomers, and the reason behind is that the two enantiomers formed are interconvertible. The two enantiomers formed the enantiomer forms are interconvertible into each other, and the process is so fast, that prediction of the actual isomer formed is quite difficult, and this process is called as nitrogen inversion. This process is called as nitrogen inversion, or we can also call it as amine inversion, or it is also called as amine inversion. So what is there? What is nitro inversion or what is amine inversion? So that we can define as that the enantiomers forms in case of amines rapidly interconvert into each other. वो बहुत जल्दी जल्दी एक दूसरे में चेंज होते रहते हैं, इसलिए हम उनको प्रिडिक्ट नहीं कर पाते, या उनका प्रिडिक्शन करना वो थोड़ा सा डिफिकल्ट होता है, जो कि इन केस ऑफ कार्बन कंपाउंड्स थोड़ा सा इजी रहता है. तो एक्चुअल में नॉर्मली in amines the nitrogen is in sp3 hybridization, but during the formation of enantiomers nitrogen acquires sp2 hybridization to attain a planar geometry. So while forming enantiomers, the nitrogen of the amines acquires sp2 hybridization, or it changes its hybridization from sp3 to sp2 to get a planar geometry, and it is somewhat like that we can understand it. and there is a lone pair of electrons. So nitrogen will acquire a shape like this, and a lone pair will be. Now here the nitrogen is in sp3 hybridization, but here it changes its hybridization to sp2 to acquire a planar structure, and again in this enantiomer the nitrogen is in sp3 hybridization. So after attaining this stage, it depends on the lone pair. If it retains on this side, then it is going to form this enantiomer. If it will shift to this side, then it is going to form this enantiomers. So it is quite difficult to identify that which one of them is getting formed at a particular time of instance. So due to this, it is quite difficult to predict the possible amines, that which of the isomer is possibly formed. I hope that you might have understood the topic. Optical activity of amines. Amines are optically active, mainly secondary and tertiary amines. So optical activity that can be understood on the behalf of their shape. Amines are pyramidal in shape due to the presence of one lone pair of electrons. But for instance of time, if we assume that the lone pair present is considered as a group, then the nitrogen atom having different groups is chiral. If we consider the geometry for as tetrahedral, and all the substituents attached to the nitrogen are different, like here that ethyl group is, then hydrogen, then methyl, then lone pair is also considered as a group, then it is going to form a non-superimposable image. Hence it is showing optical activity, or we can say that forming enantiomers. So the nitrogen atom having different groups is chiral. Now like carbon compounds, isomers are resolved easily in carbon compounds. What the isomers are formed, we can find it easily or predict it easily, whereas in case of amines it is not possible. Why it is not possible? Because the two enantiomers formed are interconvertible, and they very rapidly interconvert from one and other, and this process is called as nitrogen inversion. So due to nitrogen inversion or amine inversion, the reason is for that why we cannot resolve the possible isomers in amines. So this is the reason, due to the nitrogen inversion, or we can say amine inversion. So actually what is happening when the enantiomers are formed? So normally the nitrogen in amine is in sp3 hybridization, but forming enantiomers, it acquires sp2 hybridization, or changes its hybridization from sp3 to sp2 to acquire a planar geometry like this. And now if this electron pair stays here, then this enantiomer is going to form. If it changes its location to here, then this enantiomer is going to form. This is all about the optical activity of the amines. Thanks a lot for watching my channel.